Before any bridge is built, before any beam is placed, before any skyscraper rises, one question decides everything. Will the structure stand or collapse? That's structural analysis in one line. 1. What is structural analysis? It's the process of understanding how forces act on a structure and how that structure responds. Every building, bridge, slab, or column is basically a force-fighting system. Structural analysis tells you where the forces go, how the structure carries them, and whether it's safe. If you get this wrong, buildings crack, beams fail, bridges collapse. No exaggeration. 2. Types of loads, most important for exams. Dead load permanent. Self-weight of structural elements. Beams, slabs, columns, walls. Live load. The variable stuff, people, furniture, crowds, traffic. Exam trick, always higher uncertainty, always considered carefully. Environmental loads, wind load, crucial for tall buildings. Earthquake load, crucial for seismic zones. Snow load, cold regions. Thermal loads, temperature expansion contraction. Modern megastructures depend heavily on environmental load calculations. 3. Support reactions. Before analyzing forces inside a beam, you need to know how the beam is supported. Most common, pin support resists vertical plus horizontal forces. Roller support resists vertical forces. Fixed support resists vertical, horizontal, and moment. Rule of thumb, the support type decides the entire structural behavior. 4. Shear force and bending moment exam hotspots. Shear force, SF, the internal force that tries to slide one part of a beam past another. If SF is high, diagonal cracks appear. Bending moment, BM, the internal force that tries to bend the beam. High BM sagging, hogging, possible failure. 5. SFD and BMD, the diagrams that make or break your exam. Shear force diagram, SFD, shows variation of shear along the length of the beam, helps you identify the critical sections. Bending moment diagram, BMD, shows how bending moment changes. The maximum BM point decides the beam design. Golden rule, where shear force becomes 0, bending moment is maximum. This single rule solves 30 to 40% of exam questions. 6. Why this topic matters in real life. Beam thickness, reinforcement amount, column size, slab depth. Safety of multi-story buildings, earthquake resistance, all depend on proper structural analysis. It's not theory, it's life safety engineering. If you understand loads, reactions, SFD, and BMD, you've unlocked the foundation of structural engineering. This is the chapter every exam paper loves and every real-world engineer depends on.